should be going. All right. All right. So with some basic rules. Now I'm going to go fairly fast through some of this. Stop me at any time if there's something that happens here that you're concerned about. Okay. A lot of what we're going to do, you need to be able to do without a calculator. All right. And you guys over here, if I'm ever standing in your way, yell at me. All right, so a couple of basic rules starting with exponentials. So if I have 3 to the 5th times 3 to the 2nd, that is 3 to the 7th. Now my algebra class cannot figure out why that's not 9 to the 7th. And I keep telling them, you've got 5 3s and you've got 2 3s. How in the world do you end up with 7 9s? I don't know. You can't. It's 3 to the 7th. So good. I'm glad nobody said 9. But where we'll usually run into this is more in a problem like this. 5 to the x times 5 to the 2nd. And we can write that as 5 to the x plus 2. Okay? That kind of thing. Now, why is that an important idea? Well, because if we wanted to look at a graph of something, say a function, and it was written like this, that's not very easy to draw. But if we write it like this is the same as the 5 to the x graph, which is a graph that we'll talk about what it looks like, but it's shifted to the left too. So writing it this way is much more advantageous than writing it this way. So it's a little different take on this rule of adding the powers. Another thing we want to be able to do is go that in reverse. If we've got 5 to the x plus 2, there may be times where it's in our advantage to split that apart. And it would split apart like this. Okay? So that's one of the rules of exponentials. Another rule that we want to talk about is the power on a power. So if I have 3 squared to the 4th, 3 squared to the 4th, when you have a power on a power, what do? You multiply. So that's 3 to the 8th. But where we'll probably see that more might be in a problem such as this. Say we have 4 to the x, and we'd like to rewrite that as a power of 2. There might be a reason in a function where we'd rather see it as a power of 2. Well, what you can do is rewrite the 4 as 2 squared, correct? And now you have a power on a power. Well, this would be equivalent to 2 to the 2x, right? Because power on a power. So, again, those rules that we have, you know, the first examples I gave were kind of easy algebra 1 kind of things, but then these other ones are the same rules, but just seem a little different. So we want to be able to do that. Okay, then also with logs. Now, a basic log looks like this, okay, where this is going to be base b, okay, and I'll use b, stand for base, but the base we'll usually use will be natural log, which of course is base e. Now we usually don't write the e there. But the log we want to use is base e, natural log. We'll hardly ever do any other log. Okay? Well, the rule I want to show here is if you're multiplying these, okay, you can do what with that? You can break them into addition. Okay? And the same thing is true with natural log. So this would be ln m plus ln n. Right? We can split those apart. So anytime you're multiplying inside the log, okay, and again, that's why we want to put those parentheses. When I talk about inside the log, that's what I'm talking about, is inside the parentheses, the input of the function. All right? Another rule of logs we were talking about here earlier is when you have a power inside, you can bring that power down in front. Okay? You can bring that power down in front. Okay? That's another one that we would use. Or in reverse. If you have a number out in front, you can bring that power up as or that number up as a power. So those are some basic log rules that we want to know. Okay? All right. Another fact here is converting an exponential to a log. So if I have a log, base b of a equals, call it x, I can convert that into an equivalent form that's an exponential. Anybody remember what it is? B raised to the x equals a. So it's this b, and the way to remember that again is b is the base of the log. It's also the base of the exponential. So b raised to the x, not raised to a. It's b raised to x that equals a. B raised to x equals a. So anytime you have a log, you can convert it into an exponential. Okay, and that can be useful as well. For example, let's say we had this problem here. Log of 1 equals what? Well, what you got is b raised to something that equals what? Well, what's the only thing that can be? 0. So this is 0. Now that's true of any log. Now where we'll see it more is natural log. Okay? So ln1 is 0. Any log of 1 is always 0. Log of 1 is always 0. Okay? Now another version of that is log of b base b. What's that got to be? That's got to be 1, because you have b raised to what equals b? Well, it's got to be b to the first. B to the first equals b. And that's true with ln, that'd be ln e. ln e is 1, because what you have is log base e of e. So that's 1. All right? Now, a consequence of those two things is this. If you have b raised to the log base b of x, what does that equal? That has to equal x. Because what you're, if you put question mark here, what you'd be saying is, if you want to convert that to a log, that'd be log with this base b of question mark is equal to this up here, which is log base b of x. Well, what's question mark got to be? Got to be x, okay? So, but I don't like to have to do that every time. I don't want to do this, so basically I like to think of an exponential and a log as kind of inverses of one another, like square and square root. They kind of undo each other, square and square root. So log and exponential, same relationship. So if I have a base b exponential raised to a base b log, it's like they undo each other, and I just get x, whatever's in there. And then the reverse is true. If I have log base b, and then in here I have b to the x, that's just going to be x. I have a log base b, and inside of it I have an exponential with a base b. They undo each other. I just get x. Now the other way to think about that is you can just bring the x down in front. You can bring the x down in front. Then you have log b base b, which we said is 1. You have x times 1, which is just x. But those are some things that we want to understand. Now, what would this look like? This would look like, with e, this would look like that. E to the ln x is just x. Okay? And on this one, ln of e to the x is just x. Okay? The ln and e kind of do each other. Now, why is that? Where might you see that? I can think of a question that I've seen on the AP test, and which would be like on our final or our semester midterm. Problem like this. No calculator, multiple choice question, and they've got a bunch of graphs. Remember that one we did earlier? We did e to the 2 ln x. Remember we put that in the calculator earlier? And they give you this problem. They say, which of the following is the graph of that? Well, you look at that and you go, I have no idea what the graph of e with an ln, and who knows what that? I know what e to the x looks like. I know what ln x looks like. I have no idea what that. Well, what did we say that simplifies to? It simplifies to that, right? Because the 2 goes up into here, and then the e and ln kind of undo each other, so you end up with y equals x squared. Well, hopefully we all know what that looks like, right? And so it makes that a very easy problem. What they're doing in that problem is not trying to trick you, they're trying to test your ability to work with e's and natural logs. That's what that question's about, okay? So that's just one example of having to work with these kind of things. All right. So that's kind of the different rules of exponentials and stuff. So, all right, good. I want to give you some time to work here. And so our homework is going to be 2 different parts. And so what I want to do is two sets of appendix ones. the first set is a lot of exponential stuff. And you're going to do the evens, I think, on the assignment sheet it says. So I'm going to go through and work a few odds with you. Okay, we'll work them together here, and then I'll let you get started. Okay? So I think on the homework, it's going to be, have you guys seen this smartboard thing in action?
Nope. Am I elementary?
It's kind of cool. So we're recording the video. The video that's recording is basically just the microphone's picking up the noise, my voice, and it's recording what's on the screen. So all that stuff I was writing with the tablet obviously is showing on the screen. And so I can also take this marker, which is just a regular old marker, but this is not. And this thing here has a sensor, and so as I write, your assignment here shows up on the computer. So it's picking up the movements of the marker. And now I could have written that, I could have stuck a green marker in there and it would have still wrote black over there because I've got the black one. Now over there I've got a green and a blue and some other ones. So if I put a red one in this black thing, it'd still show up black. But anyway, on your assignment sheet, it says Appendix E is what? 26 through 66 even, right? So you're not doing all of Appendix E, you're just doing what it says on the homework sheet. So Appendix E is this, and on Appendix G, I want you to skip 1 and 5. So just cross out 1 and 5. So there's like 4 of those. Now those are story problems. Those are tough. Those are some Algebra 2 kind of story problem. Setting them up, that's always the toughest part of those problems is getting them set up. And that'll be true when we do calculus with them. The calculus stuff won't be that hard. It'll be getting the story problem set up. So that's part of your homework too. But right now, let's work on this Appendix E stuff. All right. Oops, the S didn't. Sometimes I write a little too fast. All right. So let's take a look at. Let's do number 25 first. Not number 25. That's wrong. Number 27. Oh, now this is kind of cool too. I got to erase this. So I need this special eraser. Kind of follows the action of this eraser too. Okay. All right, it doesn't take much to amuse me on this one. All right, so 27. So 27 says that g of x is equal to a times e, what is it? ae to the 0.2x. And so on 27, we're supposed to, they tell us that g of 1 is 5. So we're supposed to solve for x. Right? Now, I want you to, I'm going to show you how I kind of want you to write this out, but it's not like I'm saying you have to show your work this way, or I'm not trying to give you busy work. What I'm trying to show you here, especially, I told you our first quiz is a lot about function and function notation. What I'm trying to get across to you is speaking the language of functions and understanding how to write things will greatly help your understanding. Okay, and that's why I emphasize it so much, okay? It's not about busy work, but here's what I'd like to see you write. So when they tell you g of 1 is 5, so I'd like you to write and recognize it, okay, a g of 1 means there's a 1 put in for the x. So g of 1 means I've got a e to the 0.2 times 1. And then that also has to equal 5, because they told me g of 1 equals 5. So g of 1 means put a 1 in for x, but it's also got to equal 5. So now basically I have an equation to write. So this would be a e to the 0.2 equals 5. Now a lot of you would grab your TI-30 or something at this point and want to put things in calculator. Don't worry about that. All you need to do now is divide by e to the 0.2, and you get 5 over e to the 0.2, and just leave it. That's a number. I mean, you can put it in your calculator, get a decimal. Remember we talked about the other day about 3 decimal places? And that's fine. But if you can avoid having to worry about rounding and stuff, this is an okay answer. Now, there might be times that's not, and we'll talk about when that is and when that isn't. But for right now, just leave it. I want this homework here to be as much no calculator as possible. Okay, so just stop right there. Okay, next one, 35. Okay, 35 says to write this in exponential form. So they give you this log problem, and they want you to write it in exponential form. Now the section before this was the reverse. They gave you an exponential, said write it in log form. So what would be the exponential form of this? 5 to the negative 2 equals 1/25. That's all they want you to do. Just stop right there. Write it in exponential form. Okay? Next one I want to do is 45. Oh, we did that one already. Let's do 47. ln 1 over e. They want you to simplify this, basically. The directions actually say, use properties of exponential log to evaluate the expression exactly. Basically, they mean to simplify it. So what could we do with 1 over e? Make it e to the negative 1. Make 1 over e to the negative 1. Now what's ln e to the negative 1? It's just negative 1. Now you can bring the negative 1 down in front, and then remember that ln e is just 1, so it'd be negative 1 times 1. Or you can just remember that ln and e are like inverses of each other. They are function inverses. And so they kind of undo each other or cancel each other out. And so that simplifies the plain old negative 1. Okay? All right. See, if you guys would have taken discrete math, you'd be having a lot of fun out there. All right. I should have said that, so now like 4 people will drop.
Yeah.
All right.
Yesterday was the calculator.
This class is really hanging in there. The other section is just dropping crazy.
The way to expect that.
This is, I didn't want to say that. All right. Oh, it's recording. Oh,
Oh,
shoot.
gosh. Stricken from the record.
No, yeah, no. That class, nobody will watch it. All right. All right. 50. Kidding. Okay, 57. Last one. Last one, then you can work. All right. It says f of x equals, what is it, 20? E to the point 1x. All right. And so then they tell you, so that's f of x. And they tell you in 57 that f of x is equal to 40. So what that means is the output, right? When you see that, I want you to think output. That means the output of a function is 40. So when the output is 40, basically we're finding the input. They're telling us solve for x. Okay, so notationally this would mean that, all right, 20 e to the 0.1x has got to equal 40, right? Now we want to solve this. We want to do as much as possible without the calculator. So what would we do? Divide by 20. We always want to get the exponential or the log by itself. So we divide by 20. We get 2. Okay, what about now? Okay, there's 2 ways to do this. One is to just convert from exponential form to log form. Now that's not my preferred method, because I think that's, in some problems, harder to do. The method that works more often in more situations is do the log of both sides. That's what I'd like to do here. So I'm going to do the natural log of both sides. So it may end up taking one extra step along the way, but I think it's just a more flexible method. So if I do the natural log of both sides, I get this. Now what happens on the left side? Those cancel out, and it's just 0.1x. I mean, you could think of it as bringing this down in front, 0.1x down in front, and then the ln e is just 1. But however you do it, that ends up just being 0.1x. And over here you get ln 2. Now that's what you would have got if you would have converted this to ln 4. Same thing. Okay, ln base e of 2 would equal that. Okay? And now divide by 0.1. So you get ln 2 over 0.1. Now I'm actually okay with you leaving that. Now, what do you get? What happens if you divide by a 10? That's the same as multiplying by 10. So a little cleaner version of this would be that right there. So that'd be nice to do, but I would accept the first one. So see, we didn't need a calculator for that at all. All right, now, just for the heck of it though, let's go to the calculator one last time. And let's, if this was on a quiz and it was a calculator problem where you're allowed to use your calculator, then you could have went to menu, algebra, solve, and you could have typed in the original problem. You could have just typed 20 e to the 0.1 x equals 40, comma, x, hit enter. Now it gave me a decimal. The reason it gave me a decimal is because I put in 0.1. If I would have, let me arrow up and grab it, hit enter, paste it back down. Let me go in and change that 0.1 to a 1/10. Oh, by the way, I was going to show you guys, there's kind of a cool way to do division here. For a 1/10, see the division, see right above the division sign in blue? It's like a fraction bar. That's how you can put in a fraction. So you hit control and the divide, and it gives you a fraction, which is kind of cool. And then you can tab to go to the two different parts. So if I would have typed that in as e to the 1/10 x and hit enter, then it would give me the 10 ln2. And it did all that. So all those steps we did in between, the calculator just did that. So if it was a calculator problem, we had to solve this equation, we can just go right there and hit solve, okay? But a lot of these will be no calculator in. So again, on the homework, we want to do it like this, and we want to work on it. Okay? All right, so Appendix E, the 26 through 66 even, and Appendix G, those story problems. You got the rest of the time to get together here. Okay? If you got any other questions from the floor, whatever, I'll help you out too.
How did you put a fraction?
It was control and then divide because it's above the divide.
No.
Everybody's got a book, right?